look, we have a function for the area of a circle, right? It's pi r squared. So what is the rate of change of the area of a circle with respect to the radius when the radius is 4 inches? Rate of change of the area of the circle with respect to the radius. So I think they're talking about a circle that's expanding. So here's a circle, here's a bigger circle, here's a bigger circle. Look, the area is expanding at an exponential rate, right? This area, and then we go to this area when the radius gets double the size, and they double the radius again. You've more than doubled the area of the circle. So that's what this question is really getting at. When the radius is 4 inches, that means we want to know the instantaneous rate of change of the area when r equals 4. So to do that, we want the instantaneous rate of change formula. Limit as h approaches 0. This is one of the two that are primarily used, okay? And if you haven't seen this before, you'll want to check out a different video where I introduce this formula. But it's 4 plus h minus f of 4 all over h, okay? Where this can be our function f. You could rewrite this as f of r if you want. Okay, and we're plugging in 4 for the center. Basically, here's what it's saying. There's a y coordinate here, and there's a y coordinate here. And then these are like your x coordinates in the slope formula. You're finding the slope between two x coordinates that are infinitely close because h is getting infinitely close to 0. So two y values that are infinitely close to each other on the x-axis. You're finding the slope between 2 points that are infinitely close to each other. That's how we get the instantaneous rate of change. Okay, so f of 4 plus h just means we need to plug in 4 plus h in here into the domain variable. 4 plus h squared. And then we subtract that by f of 4, which means you plug in 4 in for r, so that's 16 pi when you simplify. We got to divide by 0 problem, so we can't compute this yet. We got to keep simplifying. And then 4 plus h squared, that's 16 plus 8h plus h squared minus 16 pi. It's all being divided by h. And then we can distribute that pi. The whole reason we're doing this is because if you've seen this formula before, eventually stuff cancels out and you can factor out an h. If you distribute that pi to everything, then it's 16 pi plus 8 pi h plus pi h squared minus 16 pi. It's all being divided by h. Look, the 16 pi and the minus 16 pi cancel out. Limit as h approaches 0. Now look in the numerator, what's left over? I can factor out 1h, so you're left with 8 pi plus pi h here. Factored out an h, that's going to make these h's cancel out, and so you're left with 8 pi plus pi h in the numerator. You don't have a divide by 0 problem anymore. You can just plug in 0. And if you do that, 8 pi plus 0 is 8 pi. So it looks like this thing, the equation of the circle is the area of the circle, I should say. All right, let me repeat. The area of the circle is increasing at 8 pi square inches per time interval. Okay. I think that's it. Yeah, we got the instantaneous rate of change.